This is my Unit 5 project by Corinne Winters. It's the linear versus exponential, and I'm in period 4. For linear growth, my equation was Sally wants to call her mom from a public phone, but she only has $15. To start a call is $5, and every minute after is 50 cents more. How many minutes can she talk to her mom before running out of money? And how many minutes can she talk with only $10? The explicit equation for this problem is y equals 1/2 x plus 5, and the recursive rule equation is the start is
Did you get biology? Isn't that the only choice? No, there was like Earth.
equals 5, and next equals now plus 0.5. Okay. She will run out of money in 10 minutes. And for
Special topics or something? I like this color.
oh wait, sorry. 10 minutes goes down here.
Yeah,
And
it's the last picture.
for $10, she can talk for 10 minutes, and she will run out
Yeah.
in
Rehearse what you're gonna say.
20 minutes.
You're gonna explain on the X and Y.
That is how much $15 can. So this is for $15,
Axis is
and this is for $10.
and I have
For the linear growth, the table is, it starts with 5 because that is how much money she has for the to start the call, and the next minute is 5.5 because you have to add $1, or you have to add 0.5, and then 6, 6.5, 7, 7.5, 8, 8.5, 9, 9.5, and 10. The graph is a straight line because it is linear. For explicit growth, the equation is Frank's mom and dad decide to help him raise money for a charity he started. They start with $15 altogether. Every week they give him 25% more. They only do this for 10 weeks though. How much money will he have after 5 weeks? 10 weeks? The explicit equation for this is y equals 15 times 1.25 to the x power. 1.25 is actually 25%. You just have to put it like that so that it'll add and not subtract. For the recursive pattern, or for the recursive equation, it's the start is 15, and the equation is next equals now times 1.25. His money after 5 weeks is $45.78. And after 10 weeks, it is $139.70. So that's dollars.
And that is population decreases by
The explicit growth table is, it starts with 0 weeks, and it goes up by 25%, obviously. And so that, it starts with 15, because that's how much money they start with, and then 18.75, and then 23.44, 29.3, 36.62, 45.78, 57.22, 71.53, 89.41, 111.76, and then finally 139.7. This is all in dollars. And then the graph, you can't really see it, but it curves. So then it would go up like that as it continues. And so that makes it explicit. The linear decay equation is Mandy's Cupcake Cafe had 30 free samples. Every 30 minutes, 2 of the samples are eaten. How many will it take for them to run out of samples? How long will it take them to run out of samples? When will they have only 15 samples left? The explicit equation is
and as you can see in year 0,
y equals negative 2x plus 30. Negative 2 is how many samples are gone in every 30 minutes, and the plus 30 is what they start with, which is 30 free samples. So that means they start with 30. The next equals now equation, or next now equation, and then now minus 2. Okay.
So that equals 0.7.
Okay. So next, they will run out in 7.5 hours.
Okay, done.
Because if you plug in 7.5 into x, it will be equal.
This is exponential decay.
Yeah. Okay. And they will have only half of the samples they started with in 3.75 hours.
This is linear decay.
For the linear decay table, it starts with 0 30 minutes, and so that concludes that they will start at 30. And since they lose 2 every time, it goes down to 28, 26, 24, 22, 20, 18, 16, 14, 12, and 10. So and then the graph is a line because it's linear, so just go straight down by 2s. The explicit decay equation is Caroline and her friends had a bag of 1,000 Skittles. Every minute, they ate 25% of the Skittles. How many Skittles will they have after 5 minutes, 10 minutes, 15 minutes? And when will they run out of Skittles?
And I got 4.
The explicit equation is y equals 1,000 5 is 1,000 times 0.75x. The start is 1,000, and it was next equals now times 0.75, because they're decreasing 25%. If they were increasing 25%, it would be 1.25.
Start is 100.
In 5 minutes, after eating the Skittles, there will be 237 Skittles left. And after 10 minutes, there will be 56 Skittles left. And there will be 13 Skittles after 15, and they will run out in 25 minutes. So that's Skittles, 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 and the last one is in minutes.
Okay, now I'm going to show you And that is 700
For the explicit decay equation,
times 0.7.
we
And I replaced
start with 0 minutes with 1,000
2010
Skittles.
is 8
Yeah,
years
1,000.
away from the start, which was 2002.
And then after 1 minute, they have 750. And I'm going to take out the decimals, and I'm going to round because you cannot have a decimal amount of Skittles. So 56, wait, 562, no, 63 because that was a decimal, and 422, 316, 237, 177, no, 178, sorry, 133, 100, 75, and finally 56. The graph is a curve, so it goes down like that and it slowly gets smaller. And this shows that it is explicit.